Hello, welcome to this video on the hypothesis test for the mean of a normal distribution. Let's have a look at this example. It's just one I've put together, very similar to the examples you'd see in the textbooks and in fact questions in an exam paper. So let's have a look. Athena Technologies sells a particular electrical component. The life of a component has a normal distribution with a standard deviation of 4 hours. So that's our parameter, first parameter. The company claims that the mean life of a component mu is 90 hours. So that's our second parameter we need. Following rumours spread by an electrical component enthusiast on Twitter that Athena Technologies is overstating the main life, the quality control department decide to investigate. They take a random sample of 25 components and find that the mean life is 88.5 hours. So you've had a good chance to look through the problem, pause the video and have a go if you wish, or you can just watch the walkthrough of it. Well, I'm going to run the hypothesis test now. So first of all, naturally, I want to do my null hypothesis, which is that mu equals 90. And the alternative hypothesis, given that we think they may be overstating, we say mu would be less than 90. You definitely need that. I've also got to define my variable x. Let x be the life in hours of a component. It's very important you do this. Now we assuming the null hypothesis. So hypothesis, we need to put these. You will be assessed on this. The examiner's looking for all these parts. X is normally distributed. 92 squared. Or 4 squared, sorry. The variance is 4 squared. The standard deviation is 4, so the variance would be 16. So there we go, we've got our assumption, but now remember we're testing for the mean of samples. So x bar, which is what we're interested in, remember this is a test on the mean of samples, will be normally distributed and we'll still have 90, but we're going to have a variance of 4 squared over 25. Well, I could probably write that more usefully, like this, 90. So that would be 4 over 5, 0.8 squared. So you've got there your standard deviation for the mean, the distribution of means, which is what we need. So that's the distribution we're interested in. We're testing against this. Now I need the probability that if I took a sample of 25 components, what is the probability that it would be less than 88.5? That's lower than what it should be. It's lower than 90, but how unlikely is it? So you would put that into your calculator. So hopefully you're okay at doing this. I don't know if you can see this. I'm going to use the old class whiz. So the normal CD. I've put it in here before, so you just do a really small number. Just a load of zeros. The upper, there you can see 88.5. Oh, I just go back actually. The standard deviation of 0.8. The mean of 90. And we get 0.0303. So 0.0304 to 3 significant figures. There you go. So then we just do our conclusion to get the final marks. Well, 0.0304 is very small. in smaller than 5%, which is what we're doing. We're doing a 5% test. You can just see out there, it's just got out of focus, sorry. So 0.05 or 5%. So there is sufficient evidence. There's sufficient evidence to reject the null hypothesis, and we can conclude that Athena is overstating the component life mean. So what we've done, we've got all the parts there. We've got the null hypothesis, the alternative hypothesis. We've defined X. We've made our assumption. We've put it into the context of the distribution of means. We've done our test. We've worked out a probability. And we have made a contextual conclusion. That should get full marks. I've just put this extra one in to find the critical region so you understand how to do this. So the critical region for this test, well, that was 1, this is 2. You think about it, there's the distribution of X bar. If I took a sample of 25, what's the probability it's going to be in this bottom 0.5%? And, well, it's 5. The probability it's going to be in the bottom 5% is 5%, but what's the value that leads to that? Well, I can do this in my calculator using the ClassWiz. So let's have a look. Menu, 7, inverse normal, which is 3. It's not very well focused to do it. There we are, that's a bit better. So I want the area 5% underneath it, 0.05. There you are. Standard deviation 0.8. Mu is said to be 90. So we work that out and we have 88.684. So X bar would have to be less than that, 88.684. Just put that to 3 decimal places. So in this case, it's going to fail. You're going to fail the hypothesis test if you like. If you want to look at it like that, you're going to be in the critical region. You're going to be able to dispel the null hypothesis if it's in this bottom 5%. And that would require the mean of the component life to be less than 88.684. So there you go. I'll just show you the question again, just so you can review that. And that is your process. Thank you very much.